All right, today we're going to talk about absolute value functions and how to graph them. Um, this is transformation notation, this equation. And all these pieces of the equation, the A, the H, and the K, will tell you what the function looks like compared to a parent. So each piece of those is going to tell you that the equation is shifted or changed in some way compared to the parent. And let's just review or let's talk about those pieces before we get into graphing. All right, the A can do a couple things. Change my ink color here. The A, if it's negative, shows a reflection from the parent. So as you see, um, the red one is the parent, and the blue one is after you shifted because of a negative sign in the function, which is right here. Okay. It can also, if A in the equation is greater than 1, it shows a stretch. It can also show a stretch. It means to stretch it out and become skinnier, a stretch. Or it can show a compression. If that A is less than 1, kind of like if you stepped on the parent and squished it down so it would be fatter. All right, the next piece is not the A, it's the H that we are looking at. If we look at the H is right here, right there in the equation. And there's not always these pieces, but if they're present, this is what happens. H up here, it shifts the vertex left or right. And the thing to know is it's opposite of the H in the equation. So if you have a positive H, you'll be going left. If you have a negative H, you'll be going right. So if you look right here, the blue one is the parent. And then when you subtracted 3, you moved right 3. And inside the absolute value bars, when you added 3, you moved left 3 to the green one. So the blue one's the parent, and the green one moves left 3, and the red one moves right 3. And you can look at the difference in the equations. The K shifts the vertex up or down. Positive K shifts it up. That's the green one. So if you add 3 outside the absolute value bars, it's going to shift compared to the parent, and a negative number shifts it down. So there's a negative 3 in the equation outside the bars, and that shifts the whole absolute value function down to the left. This is just an overview. We're going to spend some more time with this. But first, let's work on graphing the parent, and I'll show you how to do that. Okay, the first thing you want to do is find the vertex. And on the top of your notes, it says the vertex is. So vertex is the point where the two rays meet. Your absolute value functions, as you saw in the first couple slides, are these. So this is your vertex, okay? It's the low point or the high point of your graph of the absolute value. An axis of symmetry is the line that divides the graph in half into two parts that are reflections. So it's the line that divides the graph in half. The two sides are reflections of each other. So that's this line that goes right through the vertex. And since it's a line, we're always going to write the axis of symmetry in the form of a line. So it'll be x equals something. All right, this is the parent, and I want you to write in big letters that this is the parent. That means that when we we've shifted around, we're always going to compare the movements to this graph. So the vertex is, you can find the vertex in your equation. So it will be the opposite of h, k. So the opposite of h and k. So in the example of the parent, we have neither one of those things. So our vertex, or our lower high point, is going to be 0, 0. Our axis of symmetry passes right through that point, so it's going to be x equals 0. There's going to be a line splitting our parent in half that goes through x equals 0. So let's graph this before we decide on a maximum or minimum. So we know our vertex is 0, 0, so we're going to start there. So in front of that, there is a 1, so our slope is 1. We have to graph for both the positive and the negative versions, just like we did the absolute value equations. We solved it twice, so we need two sides of that v. Sorry about that. So our slope is 1, so we're going to go up 1 over 1. So we have that ray. So now we need to do it for the other side. So our slope's going to be -1. So starting here, we don't need what's down here. We're going to go left 1, up 1. So we're going to use both the negative and the positive versions, because anything inside those absolute value bars is positive. All right, so there's our parent. So minimum or maximum, do we have a low point or do we have a high point? Is our vertex the lowest point or the highest point of the graph? Well, it's the lowest point. So in this case, we have a minimum. The domain, that's how far left and right this function is. It goes on forever left at -infinity and goes forever right. The range is how far down, up and down it goes. The lowest we have is 0, because that's our vertex, and it goes on forever to 0 to infinity. So we had no transformations, like nothing happened to that, no shifts or anything, because it's the parent. All right, let's move on. This time we're going to graph y equals the absolute value of x plus 1. So remember, our vertex is the opposite of h and k. And this time we have a k but no h. So our vertex is going to be 0, and there's our k, 1. Okay, so let's graph it. Here's our vertex, 0, 1, and still the slope in front of here is 1, so we're going to graph for m equals -1 and m equals 1. So it looks just like the parent, with the exception of the fact that it has shifted up 1. Same thing, except we're moving the whole thing up 1 unit. Okay, so our axis of symmetry is still right here, still going through 0, so it's x equals 0. Do we have a low point or a high point? We have a low point of this, so we have a minimum. This goes on forever, left and right. That's our domain, how far left and right. So we have -infinity, infinity. The low point this time is not 0 anymore. It's our vertex at 1. So we go 1 to infinity. The transformations that occurred compared to the parent, we just shifted up 1. All right, moving on. Now we have x, the absolute value of x plus 1. The 1 is inside, so that's our h. Remember, our vertex is the opposite of h and k. So the opposite of h will be -1, and we have no k, so that's going to be 0. So let's go ahead and start with that axis of symmetry. So -1, 0, and look, our slope is still the same. So we're going to be the same, but this time Same as the parent, but this time it's just shifted over left. So the same function with those same rays, but just moved over one. So do we have a low point or a high point? Again, we have a low point, so this is a minimum. Our domain is still the same. It goes on forever, left and right, so negative infinity, infinity. Our range, we're back at 0 is our low point, and then goes to infinity, up. This time, the transformations are we shifted left 1. All right. Well, the next one, we got a whole lot going on here, but let's just start from the very beginning. Okay, so first we have to find our vertex. So it's opposite of h, which is 2, and k. So let's plot that. 1, 2, 1, 2, 3, 4, 5. There we are. Okay, so now we're going to graph that. So our slope is a half and negative half. So let's plot the first ray. So up 1 over 2, up 1 over 2, up 1 over 2. Okay, so now we're going to do up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. Okay, so there's still, let's look for our axis of symmetry. X equals 2. Because it's a line going through 2. That's equals. Is it a maximum or minimum? Well, we still have a low point, so it's called a minimum. The domain is still negative infinity to infinity because that will get wider and wider forever. The range, what's our low point here? It's 5. So it's 5 and then goes up forever to infinity. Transformations. Okay, let's look at all the pieces. So we have an A this time. So when your A is less than 1, it's a compression. When it's greater than 1, it's a stretch. So we have a compression. See how it flattened out compared to the parent? That's a compression. We have an H, which is 2, and it's opposite of the H. So it's a shift right of 2. And then we have a K. So it's also a shift up of 5. All right. One more. So we have f of x equals the negative 3x. Our vertex here is 0, 0, because there's no h, there's no k. So this time, my slope is going to be 3 and negative 3. Oh, let's back up the track. So I have down 3 over 1. We have a maximum this time. I'm glad we showed this example because we have a high point instead of a low point. Our axis of symmetry is x equals 0. The domain is still forever left, forever right. Our range, the high point, we're going to go the lowest first, so negative infinity, and this time we're going to put the 0 on the right side. The transformations, we have that negative sign, so it's a reflection, and that 3 is greater than 1, so it's a stretch, which makes the V skinnier, a stretch. Okay, that's it.